Now we're moving into a new unit that has to do with parallel lines. And so we're going to talk about parallel lines that are cut by a transversal. All that means is that we have a line that's intersecting or passing through a pair of parallel lines. So you can call this diagonal right here a transversal. And we're going to start with something you may have heard. They're called alternate interior angles. So what does it mean for them to be interior? Think about it. It means that they're on the inside. So if I start with this angle, then the alternate one is going to be on the other side of the transversal. So these are called alternate interior angles. Another example, which I'll do in a different color, would be these pink. If you like color coding, which I know a bunch of you do, then this is a great set of notes to get out your different colors in color code. So those same colors mean that they are going to be congruent. So those are my alternate interior angles, and you can just visually look on these to see that they are congruent. And we'll work on proving those in a couple days, but we're going to learn how to use them first. So these are congruent, and they're on the inside and opposite sides of the transversal. Since they are the same or congruent, that means that we can just set the equations or set the expressions equal to each other. Set them equal to each other. At the very end of the video, I'll have my handy dandy way of doing it so that you don't always have to remember all the naming. You can really quickly know whether things are congruent or the other option is going to be supplementary. So those are alternate interior angles. Another thing I want to point out with these is I like to, you can make them pretty easily by making a Z or a backward Z. Here's what I mean. If your top and bottom of your Z are the parallel lines, I can outline like that, and the inside part is one pair of my alternate interior angles. And if I do it in another color, have this kind of backward Z, then there are my other pair of alternate interior angles. So we're going to talk about that. That's my really shortcut way to remember how to do alternate interiors, and that's going to be a really helpful thing for us to find. So alternate exterior, that means we're going to be on the outside. So if I choose this one, the other outside angle on the other side of the transversal is there. So then I also have a different pair here. So they are on the outside part of the parallel lines, and they are on, because it says alternate, they're on opposite sides of the transversal. And they also are congruent. Since they're congruent, we can set them equal to each other. All right. Corresponding means that they are going to be basically in the same position. So if I start with this one here, corresponding is going to be kind of what looks like if I imagine zooming in on the other X, it's what is in the same spot. So I have a whole bunch of corresponding angles if you feel like coloring them all in. So I also have those who are considered corresponding, the bottom left and bottom right. So there are 4 pairs of corresponding angles. And the relationship of those is also that they are congruent. Imagine that. So they're congruent and they're located in the same position. The equations then, since they're congruent, set equal to each other. You getting used to that? Well, don't get too used to that. All right. So now let's try identifying, oh, JK, we have one more. Consecutive interior. So we're on the inside, and consecutive means next. Like consecutive numbers, it's the number after it. So it's just the next angle that is on the interior. But you can just kind of visually look at these. Those are definitely not congruent because my top angle is obtuse and my bottom angle is acute. So if you ever can't remember if these are congruent, then just really exaggerate your picture and you can usually see one will be acute, one will be obtuse. So they obviously cannot be the same. So for them, their relationship is that they're supplementary. And we'll, once again, prove that in class later next week. But for now, we're just going to use the fact that they're supplementary. And they're on the inside and the same side as the transversal. Same side of the transversal. And we're going to add them together since they're supplementary, and that's going to equal 180. So now let's look at some examples that have been mixed up that we have to think about. So these are outside, so I'm thinking that they're going to be an exterior, and they're on opposite sides of the transversal, so that's going to be an alternate exterior angle, and those are congruent. And I'll show you a really quick way at the very end to have already marked that these are congruent. So that means I can set them equal, and I just have this little two-step equation to solve. So I'm going to move the 10x to the other side by subtracting, so I get 2x equals 20. Divide by 2 and I get x equals 10. The end, amen. Going to the next problem, I noticed that these angles are in the same position. They're on the same side of the transversal, and they're also in the same position in relationship to the parallel lines, which is what we call corresponding. They correspond to each other. Corresponding angles are also congruent, so I can set the two sides of the equation equal to each other. The two angles equal to each other, really. And I have another two-step equation. So 5x equals subtract 25 from both sides, and I get 110. And then I'm going to divide 110 by 5. And so we are going to get 22 for x. Moving on. The next ones I noticed they're on the inside, so they're interior. And they're on opposite sides, so they're alternate interior angles, which are congruent. So 3x plus 10 equals 85 degrees. Subtract the 10 over, and I get 75. Divide by 3. 3/4 gives me 75 cents, so that's going to be 25. That leaves my last one to be consecutive. Consecutive means that they're the next angle, and those are always on the inside. So that was the worst you ever. Sorry. So those are consecutive, which means these are my one type that are supplementary, so don't set them equal. You usually get an answer that doesn't really make sense when you do that, if you mess that up. So 12x minus 24 equals 60. So 12x equals 84, and x equals 7. All right, you ready for my handy-dandy way that I do these? My last hint, whenever I get a parallel line problem like this, and all I'm trying to do is solve these, I'm not really needing to identify which type of angle, I color them using the alternate interior angles first, and then I use vertical angles to get everything else. Here's what I mean. You want to choose two colors, or you just mark some of these with like one little angle mark and some with two. You can also do it that way, but I love color, so we're going to do color. So what I do is I use the top and bottom of my Z is going to be my two parallel lines. So there's the top of my Z, slant of the Z, bottom of the Z, and I mark those two angles as congruent. I then use, well, since those two are congruent, what I can do is use my vertical angles. Now I know those right here need to be the same. Okay, you see how I did that? Vertical angles. And now that means all my other angles are going to be what's left over, and those are all congruent to each other. So then I know if I'm using the same color, that means I can set them equal. If I use the different colors, that means that they add to 180 degrees. So that's kind of how I shortcut it. I just always find one of my sets of alternate interior angles, then do my vertical angles. Everything else is the other color. So my only two options for the expressions I have is either set them equal if they're congruent, which means the same color on my picture, or if they're different colors, then they're going to be supplementary and I'll add 180. So that's just my handy dandy tip for how I like to solve them. Take it or leave it.